This video is going to show examples of solving the quadratics by factoring. So in a previous video I explained all the steps to solving by factoring, and again solving, when you solve, your answer will look like x equals. So we need to always make sure we go that extra step. We will be factoring, so that is the method that we're going to use. We're not going to stop at our factors. We're going to go to that next step to find basically our x-intercepts. So you're always going to find your x-intercepts. So solve by factoring, we got to make sure it's in standard form by setting them equal to 0. So our first problem is 3x squared equals x plus 4. To turn this back into standard form, we want to keep our x squared positive. So that means we're going to move our x and our 4 to the other side by subtracting them both. So we'll have 3x squared, and then we'll subtract the x, so it'll be minus x. We're going to subtract the 4, it'll be a minus 4 equals to 0. So we want to factor. Since it's in standard form, we want to factor this. The first step you do when you factor is your GCF. The smallest number on your GCF is a 1 because of that negative 1 right there. So our GCF will be a 1 so far. We have an x, and no x. That means our GCF is just 1 and it will not affect the problem. Now we'll look at how many terms we have. We still have 3 terms in our problem. That is going to use MACAB or the AC method. So our A value is equal to that positive 3. Our B value is equal to a negative 1. And our C value is equal to a negative 4. Our MAC is multiply A and C, so it's 3 times negative 4, which is a negative 12. And our AB is add to B, so our B value is negative 1. So in our chart, we're going to multiply to 12. So we start with 1 and 12, 2 and 6, 3 and 4. So up goes multiplies to A and C, and then sideways adds to B. 1 and 12 will never give us a 1. 2 and 6 cannot add to a 1, but 3 and 4 can. So we're going to get rid of the 1 and 12, 2 and 6. But to get a negative 1, we have to do positive 3 minus 4. So positive 3 minus 4. But we always want to make sure it max correctly. Positive 3 times negative 4 is a negative 12. And 3 minus 4 is a negative 1. So these are the ones we want to use. I always make a little note about my A value. Since A is not equal to 1, we must use the box. So I draw out my box over here. I don't want to go too far over so I can make sure I have enough room to do my next problem. My first term is 3x squared, so that goes into my first box. My second term is that x, which is how we got that 3 and negative 4, so those will go into those 2 boxes here. Our last term was a negative 4, so I'm going to put that negative 4 in the last box. So you know what I was talking about with that negative x? It's not going away. We're going to create it with 3 minus 4, because that gives us the negative 1. So we're going to have a 3x and then a negative 4x, because 3x and negative 4x gives us that negative x. Now we're just going to factor out our GCFs. So for this first row, our GCF is 3x. For the second row, our GCF is a negative 4. For the first column, going up, the GCF is an x. Then for the second column, it's going to be, since this sign is a positive, I know I'm going to have a positive here, that 3 was positive. So the GCF between 3 and 4 is just a 1. What I can do now is write these as our factors. So we have that x plus 1 at the top is one of our factors. And then the 3x minus 4 on the side is a factor. That's still equal to 0. Now to solve these, we take each of these and set them equal to 0. So I would have x plus 1 is equal to 0 because it has a variable with it. This one also has a variable, so I put 3x minus 4 equals to 0. And you can do this any way you want to. You can set them equal to 0. You can change the sign and divide by what's on the x. You can just think of this as finding your x-intercepts. So our 2 solutions are x equals negative 1 and x equals, I know I'm going to have to add the 4, but I have to make sure that I get my x by itself, so I have to divide by that 3. So I'm going to add the 4, so I have positive 4, but then I have to divide by 3. These are our 2 solutions. And these are 2 real rational. They're real and rational because I was able to factor them. Number 2 is actually down here, so I'm going to come down to number 2. It's already in standard form. I can go ahead and factor this. Our GCF, our smallest number is a 1. So that means our GCF is just going to be 1. So I have an x squared, x, and no x. So we have 3 terms. That means MACAB. So I'm going to do A equals 1, B equals -6, and C equals 9. Our MACAB. Our MAC is multiplied by A and C, which is 1 times 9, which is 9. And our AB is -6. So I have multiplied at 9 is 1 and 9, and 3 and 3. 1 and 9 will never give us a 6, but 3 and 3 can. I want a -6, so I have to have a -3 and a -3. Now I have to make sure they map correctly. Negative times negative is a positive, and -3 minus 3 is -6. So these are the numbers we want. Now my note is that since A is equal to 1, we do not have to use the box, so no box. We can go straight to our factors. Our factors, since we have our 2 numbers, the letter we use is x, so it's going to be x minus 3 from that one. Then we're going to have x, and then again this one was -3, so we put -3 equal to 0. Now you can see this as they're written the same way, so that means that this is really x minus 3 squared is equal to 0. Now the reason I want to point this out is because this is also vertex form. This is intercept form right now because you have your 2x intercepts, but this is also in vertex form because you have the one set of parentheses squared and there's nothing on the outside. So this is vertex form. You technically only have one value because they're the same parentheses. So what that means is that your quadratic will actually bounce off of the x-axis. So we really only have one solution. 3 minus 3 is what gives you 0. So our solution is x equals 3, a positive 3. So again, what that means is that you have only one real rational. We know it was going to be real and rational because you could factor it. We have one real rational solution. And what that means is that the parabola bounces on the x-axis. That also means that your vertex is the same as your x-intercepts because it's just bouncing on it. So then it's going to go down to the x equals 3 and then bounce back up. So your x-intercept is the same as your vertex. If we go up to number 3, we have parentheses x plus 2 squared equals 49. This is in vertex form, which doesn't help us actually find our x-intercepts. We have to put this back into standard form and then refactor it. This is not factored because it's not equal to 0. This is what a lot of people will struggle with because it says it looks like it's in factored form. If it was equal to 0, it would be in factored form, but it's not. So what that means is we have to rewrite this out so that we can put it into standard form. What that x plus 2 squared really means is that you write out x plus 2 times x plus 2. That's where this part came from down here. We wrote it out squared because we had it written twice. So we're just undoing that. This is still equal to 49. So now we just distribute this. So x times x is x squared. Then we have x times 2 and another x times 2. So that's going to end up being 4x. Because x times 2 and then 2 times x are both 2x's. 2x plus 2x is 4x. But then we have that 2 times 2, which is equal to 4. So positive 4 equals 49. Now to put it into standard form, we have to subtract the 49. So if we subtract the 49, we'd have x squared plus 4x, and then 4 minus 49 will be negative 45 equals to 0. Now that it's in standard form, we can factor it. Our GCF will be a 1 because our smallest value is 1, and we don't have an x on the 45. So we can go straight into 3 terms as MACAB. A is equal to 1, B is equal to 4, and C is equal to negative 45. So our MAC is 1 times negative 45, and our AB is 4. So we have multiplied to 45 is 1 and 45, 3 and 15, and then 5 and 9, and that's it. Now 1 and 45 will never give us a 4, 3 and 15 will never give us a 4, but 5 and 9 will. We want to get 5 and 9 to give us a 4 by subtracting the 5, but having a positive 9. So again, we've got to make sure it max correctly. Negative 5 times 9 is a negative 45. And then 9 minus 5 does give us a 4. Our note is that A is equal to 1, so that means no box. So we can go straight into our factors. Since it's no box, we have parentheses. X is our letter. Then our first part is going to be that minus 5. Parentheses. Then we're going to have X again because that's our letter. The second one is that plus 9 equals to 0. Our x-intercepts. The first one, X will be equal to a positive 5 because 5 minus 5 gives you 0. Our second one will be X equals to a negative 9 because negative 9 plus 9 gives you 0. These are our two solutions. It crosses twice on the x-axis. On number 4, we don't have any parentheses in here, so we just got to put in standard form. Our quadratic term, that 24x squared, is on the right-hand side, though it is positive, so we actually want to keep it positive. That means we're actually going to move the x and the 3 to the right-hand side. But I'm going to keep it written as on the left, so I'm just going to move this, but I'm going to say equals to 0 at the end. So I'm going to keep my 24x squared. It's going to be positive. But then when I move the x, when I subtract, it'll become a minus x. I'll subtract the 3, it'll become a minus 3. I could have the 0 equals on this side, but I generally always like to have equals 0 on the right-hand side. It's just a preference. Now that we have 3 terms, we need a factor. Our GCF is going to be a 1. Our 3 terms are going to be using MACAD, so A equals 24, B equals negative 1, and C equals negative 3. MAC, AB. Our MAC is going to be a negative 72, 24 times negative 3, and our AB is negative 1. So our MAC, since it's negative 72, we're going to have 1 and 72, 2 and 36, then 72 divided by 3 is 24, then we have 4 and 18, then we have 6 and 12, and then we have 8 and 9. And then that's all of your factors of 72. We need to give it to a 1, so 1 and 72 will not work, 2 and 36 will not, 3 and 24, 4 and 18, and 6 and 12 will not. But 8 and 9 will get you to a negative 1. If we subtract the 9, we have a positive 8. So we have 8 times negative 9 does give us a negative 72, and it will subtract to a negative 1. So our note is A does not equal to 1, so we have to use the box. So inside the first box, we put our 24x squared. In our last box, we put the negative 3. And in the corners, we have our positive 8x and our negative 9x. GCFs for the first row of 24 and 8, smallest number is 8. 24 can be divided by 8, so 8x. The second row is that first term is negative, so I know it's going to have a negative. And between 9 and 3 is 3. In our first column, we're going to have a positive. GCF of 24 and 9 is actually going to be a 3. And then x squared and x is an x. The next column, since our first term is positive, we're going to have a plus. The GCF between 8 and 3 is just going to be a 1. So our factors become, parentheses, we're going to have our 3x plus 1 from the top, and then 8x minus 3 from the side is equal to 0. Our two solutions are x equals, we're going to have to subtract the 1, but then divide by 3, so it's going to be a negative 1 over 3. X equals, the second one, we're going to have to add the 3 and then divide by 8. So we're going to have a positive 3 over 8. So our solutions are negative 1/3 and 3/8. Now, another way we can write our solutions are x equals just negative 1/3, comma, 3 over 8. Just like that. That can show us what both of our solutions are. Another way you can see solutions be written are when they're in the squiggle bracket. We'll have a negative 1/3, comma, 3 over 8, and we'll have a closed squiggle bracket that tells you what your two solutions are. That's just another way of writing your solutions. You can continue writing them like this, but please understand that this is one way. These two ways could be ways that you see them in the future. So just understand that they're just talking about your solutions. These are not coordinates. Number 5, we have no parentheses, but we still gotta get into standard form. Our quadratic is a 7x squared. It is positive, so we want to move that 21x to the other side. So we have a positive 7x squared minus a 21x equals a 0. We want to factor this by doing our GCF. GCF, the smallest number, is 7. 21 can be divided by 7, so our GCF is equal to 7 so far. And both of these terms have an x, so our GCF is 7x. So we put that on the outside of the parentheses, and then we divide by 7x. 7x squared divided by 7x is x. Negative 21x divided by 7x is negative 3. It's equal to 0. Now, inside the parentheses, we still have two terms, so we look for a difference of squares. X is not a perfect square, so that means that this is as factored as it gets. Now that we factored it, we can actually set both of our factors equal to 0 and solve. This has an x with it, even though it's not in parentheses. So we still take our 7x equal to 0. So the question is, 7 times what gives you 0? 7 times 0 gives you 0. So our first answer is x equals 0. And then we have what minus 3 gives you 0. So x, the other one is x equals a positive 3. Those are our two solutions. Just because you factor your GCF doesn't mean it's not right. GCF could be the only thing that you can factor. Our last problem is actually the most tricky one because it's no longer just an x squared, it's an x to the 4th. This is called a quartic. You probably will not see many of these if you're in a Math 2 class, but I just wanted to show this, that you factor it very similar to what we've done before. So we still want to get into standard form, so it will become x to the 4th minus 8x squared, and then plus 12 is equal to 0. We still actually factor it the same way as MACAB. It's just that in our parentheses, we're not just going to have an x, we're going to end up having an x squared in each of them. So we're just going to do a equals 1, b equals negative 8, and c equals 12. So our MAC is going to be at 12, and our AB is at negative 8. So we have 1 and 12, 2 and 6, and then 3 and 4. 1 and 12 will not work, 2 and 6 will, 3 and 4 will not. So to get 2 and 6 to work, we have to have a negative 2 and a negative 6. Negative 2 times negative 6 does give us a positive 12, so these work. Our note is that A is equal to 1, so that means no box. It means we go straight to our factors. Now, in our factors, as I was saying just a second ago, we have an x to the 4th. So instead of it just being x times x, it has to be x squared times x squared. So we'll have x squared because we want to get back to an x to the 4th. Our first part has the minus 2. And the next one again will be x squared because when we multiply this back through, it would be x squared times x squared. Then we're going to have that, the second part is that minus 6 equals to 0. Now what we do here is that we don't just say it's equal to 2 and equal to 6. We actually have to set them equal up to 0 and solve. So we have x squared minus 2 equals 0, and x squared minus 6 equals to 0. Now this is just a basic equation. We want to add the values to the other side, so we're going to add the 2. So it's going to be plus 2. We have x squared equals a positive 2. We're going to do the same thing with our 6. So we have x squared equals to 6. Now, in order to solve for x, you're actually going to have to undo the square. So the inverse operation of a square is square rooting. We're going to take the square root of 2 and the square root of 6. Now, because it's an x to the fourth, this actually tells you how many solutions you should have. So we should have 4. At the moment, we really only kind of have 2, where it's the square root of 2 and square root of 6. But whenever you take the square root of something, you can think of it as what squared gives you 2. Well, a positive times a positive will give you a positive, and a negative times a negative will also give you a positive. So not only do we have the 2, the square root of 2, so we're going to have x equals the square root of 2, but we're going to have both the positive and the negative value of that. Because a positive square root of 2 and a positive square root of 2 will work, and a negative times a negative will also give you the positive. So we'll actually have the same thing for the square root of 6. So x equals, we'll have the square root of 6, but we actually have both the positive and the negative values. So now we actually have 4 values. We have the positive square root of 2, the negative square root of 2, the positive square root of 6, and the negative square root of 6. So the way we can write our answers is x equals plus or minus the square root of 2, comma, plus or minus the square root of 6, because those are our 4 answers. Now, these are real because we did not take the square root of a negative, but we have 4 answers. So I'm going to write a little note that we have 4 answers. They are real, but they are not rational, because if I were to take the square root of 2, it's going to give me a decimal that will never turn into a fraction. Square root of 2 and square root of 6 are both irrational. 4 real, irrational. These are the types of solutions we have. This was just, I wanted to show another way of looking at quadratics. This is again called a quartic. We can factor it the same way because this is in quadratic form, because it's still x squared squared and x squared, so that's why it's still in the same form. You probably will not see many of these in a Math 2 class. And again, the quartic will factor the same way as the quadratic if it is in this format. When you have x to the fourth and x squared and then a constant. You have irrational numbers because square root of 2 and square root of 6 are not rational.